In this video I'm going to look at how you can calculate the gradient m and the intercept c in the equation for a straight line y equals mx plus c. And this video is in response to a question I've often been asked by my students about how we do this type of calculation. How do I find m and how do I find c? Now, in some of my other videos I've shown how to calculate the size of an unknown protein or DNA band on a gel. And in those videos I just sort of say, and then I calculate m and I calculate c, and I've never really explained it. So this video is an attempt to explain how I derive m and c so I can then determine the value, the size of the unknown band. This is some data from a DNA gel. Now, if you're not familiar with this data, then I suggest you look at my DNA gel videos, which are linked below in the description. There should also be a link in there for the protein gels. So here's my gel data. I've got the base pairs in size. These are known sizes from the DNA ladder. And then I've converted those sizes, those base pairs, to the log value. I also know the distance travelled by those bands from the well of the gel, and here you can see I've measured them in millimetres. And if I plot these data with log base pairs along the bottom of the graph, because that's the thing that you know, against the distance in millimetres up the side of the graph, because that's the thing you're measuring, you'll get something that looks like this with a straight line. And in my earlier videos on how to determine the size of an unknown band on a DNA or protein gel, I've given graph details. And what I've said is something like this. This graph has a gradient m of minus 22.091, an intercept on the y-axis of 103.43, and a fit of minus 0.9990. And the question I keep getting is, how do you calculate these numbers? Well, there are three ways that this can be done. You can do it from the graph, you can do it from the data on the graph, or you can use Excel or Apple numbers to do the calculation. So first, let's have a look at how we can calculate the value m and the value c from our graph. Here is our equation for a straight line, y equals mx plus c. So m is the gradient, and all the gradient is the amount of rise you get for distance travelled. So what we need to do is draw a biggest triangle possible on the graph. And to do this, what I do is I select a value at 50 and I draw a line across, and then I drop it down to the log base pair axis. Next, I draw a line across from 20, again intercepting the line of the graph. And the reason I use 20 and not 10 is because if I use 10, the line won't intercept the graph. So therefore, I can't do it at 10. But this is the biggest triangle I can draw on this graph. And as we all know, 50 minus 20 gives us a value of 30. So this means we've got a rise of 30 here, 30 millimetres. The next thing we need to do is calculate the distance travelled to get that rise. So to calculate that, I take the 20 line and I drop another line down to the log base pair axis. I can then say that the distance travelled, this distance here, is 2.41 minus 3.78, which gives me a value of minus 1.37. Now the reason this is a negative value is because we're effectively travelling backwards across the graph. We're going from right to left. If we were going from left to right, it would in fact be a positive value because this line's got a negative gradient. So with that information, we can now calculate the gradient m. We can say that m is equal to 30, the rise, divided by the distance travelled, which is minus 1.37, which gives us a value of minus 21.9. And that is our gradient, our value for m, minus 21.9. We can then plug that into the equation. We can see that y is equal to minus 21.9 multiply x plus c. The next thing we need to do is calculate c, and c is the intercept with the y-axis. So you might think here you could just extend this line and it's sort of going to intercept around about 60. But you can't, because you need to note that along the bottom axis we're not at x equals 0. We're actually at x equals 2. So we can't do that. On this graph, it is not possible using the graph to determine the value for c. So what we do is we take a point that is on the line, and we know one of these points, 2.4150. We know that value, and we can plug that value into our equation. So y equals minus 21.9 x plus c in fact becomes y is equal to minus 21.9 multiplied by 2.41 plus c. So that is the x value going in, and then we can add in the y value of 50, and that gives us 50 is equal to minus 21.9 multiplied by 2.41 plus c. We can then do the math, so 50 is equal to 52.78, so all I've done there is multiply the minus 21.9 by 2.41. We can then move that negative 52.78 across the equation, and that gives us 50 minus 52.78 is equal to c, and therefore we can solve that for c, and we can say that c is equal to 102.78. Therefore, y is equal to minus 21.9 x plus 102.78. So therefore we've solved for m, 21.9, and for c, 102.78. So that is how you solve for m and c using the graph. You draw a biggest triangle possible, calculate the gradient, and then either look for the intercept on the axis, keeping in mind that you've got to do it at x equals 0, which we can't do on this graph. If we can't do the intercept, we can then use a value on the line to calculate the value of c. So what about using the data on the graph? This is most probably the most difficult way to do it, because what we'll have to do is something called simultaneous equations. So if you're not familiar with those, then this way can be a bit tricky. So stick with the first method. So here's our graph again, y equals mx plus c. And what we do is we take two data points that are on the line. So we take the one at 50, as we did in the last example, and that gives us 50 and 2.41. So we have a point there on the line. We do the same at 20, and that drops down to 3.78. So we can say we've got a point on the line that is 2.4150, and we've got another point that's 3.7820. And we just substitute these values into y equals mx plus c. So let's take the top one there, the 2.4150. So we put that in, and that gives us 50 is equal to m multiplied by 2.41 plus c. What we then do is rearrange the equation. We move that m multiplied by 2.41 over to the 50. So we can say that 50 minus m multiplied by 2.41 is equal to c. So now we've got a value for c. We can say that c is equal to 50 minus m multiplied by 2.41. We then take the second point, the 3.7820 point, and we put those values into the equation. And what we can see here is we've got 20 is equal to m multiplied by 3.78 plus c. Now we know from the first point that c is equal to 50 minus m multiplied by 2.41. So what we do is we replace c in the second equation with the value for c calculated in the first equation. And this gives us 20 is equal to m multiplied by 3.78 plus 50 minus m multiplied by 2.41. Seems complicated, I know. All you have to do now is rearrange this equation, and you can solve for m. So the first thing we do is we move the 50 over. So 20 minus 50 is equal to m multiplied by 3.78 minus m multiplied by 2.41. So that means that minus 30 is equal to m multiplied by 3.78 minus m multiplied by 2.41. Next we isolate for m, so we move it out, and we can say that minus 30 is equal to m open brackets 3.78 minus 2.41. We can then calculate the value of 3.78 minus 2.41, which gives us a value of 1.37. We can then move that across and say that m is equal to 30 divided by 1.37, which gives us a value of minus 21.9. So there we've calculated the gradient using simultaneous equations. Now that we know m, we can go back to y equals mx plus c and substitute in for m, which is minus 21.9. We then put in the values from the graph. I'm going to use the upper value, so we can say that y is equal to minus 21.9 multiplied by 2.41 plus c. We put in the other value for y, so we say 50 is equal to minus 21.9 multiplied by 2.41 plus c. We can then rearrange this equation. We can then do the calculation. We can say that 50 is equal to minus 52.78. I've just multiplied the 21.9 by 2.41. Don't forget it's negative. And that gives us 52.78, a negative number. So 50 is equal to minus 52.78 plus c. We then move the minus 52.78 across to the other side of the equation. So we have 50 minus 52.78 is equal to c. And that means that c is equal to 102.78. So this gives us the equation that y is equal to minus 21.9 x plus 102.78. So again, we've solved for m, it's minus 21.9, and c, which is 102.78. Now the third and final way of doing this calculation is to use Excel or Apple numbers. So here again we've got the table that I showed earlier, and what we do is add in an extra line, and I always label these x and y so that I don't get them mixed up. I then use the slope formula in Excel or in Apple numbers and make sure that I select the correct values. So there we've got slope y, slope x, and there is our gradient, minus 22.091. I do the same with intercept. I use the intercept function. I select the y values, I select the x values, and there is our intercept, 103.043. The fit, which we can't calculate easily from the graph, here we use the correlation function, and again we select the y values and we select the x values, and that gives us our fit, which in this case is minus 0.999. So a very good fit indeed. So that's the third method, and that is how you can calculate the value using Apple numbers or Excel. So in summary, in this video we've looked at the three methods we can use to calculate the gradient m and the intercept c for y equals mx plus c, the equation for a straight line. We've looked at how to calculate it from a graph, we've looked at how to calculate it from the data on a graph, and we've looked at how we can use Excel or Apple numbers. Now, if you need more help with drawing your graphs, then please check out the video up in the top right hand corner on how to draw a graph. And if you're generally struggling with your lab maths, then you might find the playlist that I have available on lab calculations also useful.